this problem, we want to simplify the expression. So we got 5 over x plus 3 plus 15 over x plus 5 all over 2x plus 7 over x squared plus 8x plus 15. Well, this one, we actually have to factor all of our inner denominators. Now, let's refresh our memory what the inner denominator is. We got fractions inside of the fractions, and they have their own denominators. And those are going to be our inner denominators. Well, x plus 3 we can't do anything with. X plus 5 we can't do anything with. But x squared plus 8x plus 15, that's PSD. So let me factor it over here. So I got x squared plus 8x plus 15. PSD because it's x squared, no number in front of the x squared. With the PSD, we take the number at the end, ignoring the sign if there was one. Come up with our 3 columns. P column, that's all the products that give us 15. We got 1 times 15, 3 times 5. Now the sum column, S for sum. We're going to add them together. 1 plus 15 is 16, 3 plus 5 is 8. The difference column, subtract smaller from larger. 15 minus 1 is 14, 5 minus 3 is 2. Number we're looking for is a number before our middle term, which is 8, which is right here. So I'm going to use 3 and 5. Now our larger number in the P column that we're using, which is 5, will always be the same size as the middle term, which in this problem is positive. The number I circled in the S column, S for same signs, they're both positive, both negative. So since this is positive, this one will be positive. So this becomes 5 over x plus 3 plus 15 over x plus 5 all over 2x plus 7 over x plus 3, x plus 5. Okay, now remember what our inner denominators are. That one there, this one, and this one. Now to simplify this, we need to figure out what the LCM is of all our inner denominators. So I'll start with my first factor, the x plus 3. I'm looking for the greatest number of x plus 3's in a single inner denominator. There's 1 here, none here, 1 here. So the greatest number of x plus 3's in a single inner denominator is 1. Then I go to the x plus 5. I'm looking for the greatest number of x plus 5's in any single inner denominator. There's none here, 1 here, 1 here. So the greatest number of x plus 5's is 1. So this is our LCM, and this is what we'll multiply everything by. So we'll multiply times the 5 over x plus 3. We'll multiply it times the 15 over x plus 5. And we'll multiply it times 2x plus 7 over x plus 3, x plus 5. Well, this x plus 3 cancels this x plus 3. This x plus 5 cancels that x plus 5. This x plus 3 cancels that x plus 3. And this x minus 5 cancels that x minus 5. Now notice all of our inner denominators have disappeared. So now we're left with 5 times x plus 5 plus 15 times x plus 3 all over 2x plus 7. Well, let's get rid of these parentheses. 5 times x is 5x. 5 times 5 is 25. 15 times x is 15x. 15 times 3 is 45 over 2x plus 7. Combine together like terms. 5x plus 15x is 20x. 25 plus 45 is 70? 60, 70 over 2x plus 7. Well, we got rid of our inner denominators, and now, after we combine together like terms and so forth, we want to factor the top, factor the bottom. Well, top part factors with GCF, bottom part doesn't factor. So top part, they're both divisible by 10, so I factor out a 10, and that leaves us 2x plus 7. Then we cancel if possible. Well, these both have a 2x plus 7, so those cancel. And our answer is equal to 10.